Important disclaimer before we start, all the data we're using is from our 102's 2022 season, which was 3 events, Mount Olive, Montgomery, and FMA champs. And we compared that data and our predictions against results from the Blue Alliance, which pull right from first, but you should know that. And obviously the accuracy of your predictions will depend on how good the data input it is at that competition. Yeah, so this is the first graph. This was pretty simple. This was the first one I made. It's just looking at the prediction accuracy of our data at FMA champs at Lehigh Valley. So the prediction accuracy one you could tell is that's obvious. But the thing on the x-axis, confidence threshold, this is important because this is going to show up later and it's going to be like kind of more confusing later. This is not like a range. So down here where it says like 0.5, that's not only the stuff that's 50% confident, that's 50% all of the matches. And then here it's not 70, it's not just 7, right? So important takeaways from this from this graph, all of our matches right here were about 73% accurate, which is like kind of scary, I think. You know, if all of our matches were getting 73% accurate, that's a pretty good shot that we're gonna get it right in future events. And up here, the one that I said was gonna be more disheartening for you guys. Right here, when I did this, I looked at the actual numbers. This is 89% right here, the spike up to 100% accuracy. So at least at our competition at FMA champs, if we were 89% confident or more that this team was going to win, or this alliance was going to win, they won. So obviously that depends on how good the data you put in is, but like, you know, if it was above like 95%, it's still like pretty guaranteed in their favor.
But they're still the champs.
Yeah, I mean it's still nice not to see 100% and see like 90-something% instead,
I mean,
but it's like
we actually we made a change to make it, instead of saying 100% when it's 99.99999, it'll actually say 99% if it's 99.99999.
Yeah. So I'm very sorry I had to share this graph and just break your hearts that even the 99% and 98% means you. Yeah, very sorry. Okay, this is statistics thing. Very important. It's how we calculate averages for Scoutradioz, not just for predictions, but just across the entire app. Whenever you'll see an average for a team of points, it's using this formula. This is what's called you can see exponential moving average. What it does is it weights the most recent value by a percentage compared to the last average. So alpha is the main factor in how weighted it is. A lower alpha value will mean the newest term, which is a sub t, is weighted less. Lower alpha is weighted less, and the previous average, s sub t minus 1, is weighted more because it's the opposite. And as alpha goes up, that flips. At current, at last season we were using 0.4 as our alpha value. So when you got an average, 40% of that average was the previous like match that they played, and 60% of that average was the last average. Right. And this is what I want to look at for the next set of graphs, was like how do different alpha values affect our prediction accuracy, and is there a better one, right, than 0.4? And this is what I got, and there was a better one than 0.4. 0.4 wasn't bad, but it definitely was not the best one we had. So this is a lot to break down. Very overwhelming at first. Just look at this one graph from champs. There's 3 kind of axes. There's confidence threshold, which is the different lines. Same thing before. This yellow line is not 60% to 69%. It's 60% and above, all the way up to 100. So keep that in mind when you're viewing this. So this blue line on all of these is all of the predictions. And the higher the lines go, it restricts it more and more, but it's not a specific range the whole time. Prediction accuracy up here, and alpha value, which was the thing we just talked about right here. It's the weighting. So as you can see, it's like generally Montgomery higher thresholds excluded a downward slope, which was kind of not what I expected it to be when I was doing this at first. I expected it to be like middle of the pack alpha values, maybe even higher ones would be better. This was kind of surprising to me. Um, like me and Callum, Mr. O'Connell, Tyler, we were all talking about this back when I got these graphs first and shared them with the 102 guys on Slack. I think my takeaway was that 1.5 or 0.15 was the best alpha value, which was surprising at least, because you would expect, right, with how often matches like robots change, and how after a match you go back in the pits and everybody's scrambling to do something, you would expect that like a higher one would make sense because like a higher one is more variability, and so if people are changing things all the time, you'd expect their results would change, but actually they really don't. Strangely,
So an alpha value of 0.1 means it is not decaying much, correct?
yeah, point lower alpha value will mean it's gonna be more weighted towards the average rather than more weighted towards the earlier matches and the previous averages than the newest data. So this is like, so lower is like less predictable, less variation. Higher is like less, or lower is more predictable, less variation. Higher is less predictable, more variation. So
I see, thank you. Also, could you explain to the audience and also to me, though I have a vague idea, why is it that the confidence threshold of 0.5 represents the all of your predictions rather than confidence threshold of 0.1?
yeah, I'm so sorry. I forgot to mention that when we do our our predictions on the website, we always show the team that is likely to win. It's not the team that's likely to lose, or always the red alliance, or always the blue alliance. It's always the greater one, and so I replicated that in my data as well to keep it accurate with the website. So when you're looking at a match prediction, it's never going to say 20% chance red wins or 80% chance red loses. It's always going to be like 80%. It's going to be something 50% or greater. This team wins.
If I could paraphrase, so every match will have at least a 50% confidence for
Yeah.
one team or the other. Then
Yeah.
like let's say Sean draws that. Let's say Sean filters out. Okay, we're gonna not look at the matches where the confidence was 50 to 59%. We're only look at 60% and above. That would be in this graph the orange line, the
Yeah.
0.6. That means, hey, here's all the matches where we're ignoring the ones that were like coin tosses, 50 to 59%. So that's why, generally speaking, the prediction accuracy goes up.
Yeah. Yeah. That's exactly right. I thought the threshold was. I mean, ranges are nice, but I thought threshold made a little more sense personally, because it's like we can get that we can have one line where we get a sense of the whole thing, and it still gives us an idea of what's going on. So I don't know. I don't really have anything else to talk about. I found what we thought was the best alpha value, and some interesting things about the statistics we used and all of that. So now, questions. If something was unclear or you want to know some extra information, hit me. Go for it.
But nobody jump in at once.
So, could you actually go back to the previous slide?
Yeah.
You said that the alpha value between 0.1 and 0.2 was most accurate. Is that correct?
I said 0.1, 0.15 and 0.2 were where, like, kind of I landed with what I thought was the best. Um, I think also there's this one thing I forgot to mention. Monty, even though it kind of has a weirder trend, the scaling on the y-axis is higher than over here. So, which is why, like here, if it was like high confidence, a higher alpha value would be better. A low alpha value is still like really good, and the blue line is representative of all the matches. So that's why I kind of took these graphs into consideration more because they change more.
Right.
We're
Whereas
just generally
Montgomery
better at.
is just more of a mixed bag.
What do you say?
Hmm.
Sorry.
I was just saying, whereas Montgomery is more of a mixed bag, the FMA champs and Mount Olive were more consistent, had a better trend.
Yeah. Which was kind of weird. At least for Mount Olive, for champs, it made sense. But yeah, that was kind of everything. And even in Montgomery, like all the matches, this blue line, which is everything, has a slight downward trend. So even there, it's still somewhat lined up with the other matches.
Something that might help if we kind of look at these charts would be maybe get all the y-axes to be the same range, so have them all go from 0.60
Yeah.
to 0.95. Because the Monty, if you think about it, Monty's actually really consistent. It goes from the y-axis is only a range of 0.1 overall, from 84% to 94%.
Yeah.
Even for like the 50% matches, we were 84% accurate.
Yeah.
Overall,
That would probably be a good idea. I was still getting to grips with all the software and tools I was using at that point.
Right. Because I mean,
I should have thought of that in advance.
if you stuck Monty on top of the FMA champs chart, all the Monty lines are basically at the top of the FMA champs, because that tops out around 0.85.
Yeah, it's actually like really high.
Yeah. So I'm working on some other stuff right now, more related to 102, but I could definitely go back and revise some of these graphs. I still have the code for that. I can come back and revise these graphs, make them look better if that helps with some other analysis you guys might be doing.
Yeah, sure. This is always an iterative process.
Yeah.
And if folks want, I actually have dialed up, just for a brief background, because this is if anybody's not sure about the predictions in the first place, I can kind of go over quickly just the math behind the predictions. I know you showed that.
Oh yeah, this was more about the like data, the
deeper
like
analysis
results, but yeah, the math behind it is very interesting. It's not too complicated statistics. It's not like we got an AI running on the Scoutradioz servers. This is just like basic statistics you could look up in like 15 minutes.
The fall semester, I actually made a machine learning algorithm to do predictions.
Yeah, but we're not using that in the
in
the website. It's just math.
Very rudimentary, to be honest.
And that was using the first
Correct.
published data as opposed to the scouting data.
Yes.
So there's a lot more first data, but it's nowhere near as detailed. And we don't have enough. We don't have enough scouting data.
I mean, I probably could have used the first data, but I thought it was like it would make more sense for at least us and the program to use our scouting data, so we get a more realistic view of accuracy and stuff with human error.
Yeah, and we can't do the predictions with the first data.
Yeah.
So if there's no other questions, I'll do the quick, I'll do the quick overview of the.
Yeah, go ahead.
Well, first, thank you very much, Sean, for the presentation.
No, thanks.
For doing all this math.
It's fantastic. I mean, this is great.
Yeah, there's one day where I came in, I did this for like 2 hours, I want to say, straight, and my head hurt. It's like it was not like pounding, but it was there. It was a lot.
It's definitely interesting that the 0.15 works out better, at least for
it's strange, right? I didn't expect that. But that was kind of, if you look at the graphs, you can kind of see like the lower alpha values were generally a little bit better.
Yeah.
We're generally like better than the higher ones.
I suppose that's probably because we are averaging more values, like because beforehand we were doing essentially an alpha of 0, right?
Yeah.
So we have more matches into consideration. It's a nice mix.
Yeah. All right. Any other questions? Any other things you guys want to add? Anything else?
I think Ben and Thomas can't speak, but you're lying. Did you have any questions or any comments?
Yeah, you can put them in voice text if you want as well. If you can't talk and you have a question, you can put them in there.
I don't exist.
You exist.
All right.
So if I share my screen, will that be captured in the same recording?
Yeah, because I'm just recording, or Yeah, I'm just recording my screen right now. So if I disconnect and you share, I'm still recording it.
Okay. Share my screen. Whoop. Uh-oh. Come back. This one. So do you guys see this?
Yep.
Normal?
Okay.
Yep.
Okay. So with all, so the data we collect from the scouting forms, and actually we have an example of, this is the pit scouting form, but the match scouting form is pretty similar. Check boxes, counters, and such.
You, Mr. Connell, you good?
Uh-oh.
uh,
I'll ping him. No, we cannot hear you.
yeah, you cut out your. Oh.
It's not a presentation if we don't have technical difficulties.
I might be able to get something up. Okay, what is it? I could just share my screen right now.
Sure.
All right, so this is how we're doing comparisons. It's just something called the Z-score. I haven't taken statistics yet, so I'm not 100% sure what a Z-score is.
Can you
But
guys hear? Can you guys hear me?
Yes.
I can hear you now. I took over
Ah.
your presentation.
Weird. All right. Well, so if you've got the screen being shared, whoa, that's cool.
Yeah, this is just the first website that popped up.
Okay.
Yeah. So
So basically, if you scroll up a little bit, where those overlapping things are, we score. We capture, what the scouts enter. We turn that to how many points each team is scoring, contributing to the match. I'm gonna say, somebody go, uh-huh.
Uh-huh.
yeah.
Okay, because I just make sure you guys can still hear me. So once we know how many points each team is scoring each match, we can then get the average and the standard distribution of their scoring. After like say 3 or 4 matches, we got a pretty decent idea of their own individual bell curve. So when an alliance comes up, you add up all the averages and all the standard deviations, you get basically the bell curve for that alliance.
And then
Once you have 2 bell curves, you want to know what are the odds that a point in one of the bell curves will be higher than a point in the other bell curve. If they're really overlapping, it's like 50-50. But if the 2 bell curves are pretty spread apart, it's almost 100% chance.
Yep.
And so that's what that equation is that Sean's got there. You take the difference of the 2 averages divided by the square root of the squares of the standard deviations, kind of like the Pythagorean diagonal of the 2 standard deviations. What that gives you is basically how, that makes a new distribution, one single bell curve with a line really far, to the right or to the left of the center, and that's that Z. That Z tells you how many standard deviations out it goes. So like one standard deviation is basically right where the inflection point is. It's about 62% or so. 2 standard deviations is about maybe 90%. I think 3 standard deviations like 99.7. It goes up pretty fast.
Yeah. Then you plug that in. You take that Z-score. You plug it into a Z table, which turns it into a p-value, which is percentage, or you use like a.
If you go to the BC text channel, Sean, I have a link to a Z table, so you can pull that up.
And also, I think you mentioned that you're not sure what a Z table is. If I recall correctly, the Z table is just the result of a bunch of calculus. So you
Yeah.
have the table. It's a lookup table, so you don't actually have to do the calculus yourself.
Right. So scroll down a bit because we don't look at negative z's. We only look at the positive z's. So like a positive z of 1.00. So basically, the first column is just the 1 point and then the first digit, and then you add more digits. So like 1.00, oh, that's 84%. Okay, so from 50%, so if it's right in the middle, it's 50%. One standard deviation, now you're talking about 84% chance that it's going to fall to the left of that line, that gray area. Two standard deviations, now it's like a 97% chance, etc. So we were having situations where, some alliances were just so overpowered, so OP, that their Z-score was like 5. And these tables don't go up that high.
Yeah, we had
But
4 nines.
there's still a chance, because, you never know what's going to happen, right? Somebody's battery could die, somebody could be like red carded or something. I mean, so that's why we floored the actual number. Even if it's 99.99999, that shows up in the UI as 99%.
Mm-hmm.
To save their precious hearts.
Right. So now getting back to the averages, that's what Sean's done the analysis on. We used to just average all the matches flat, but that doesn't really reflect if a team's adapting and getting better, or on the flip side, getting worse. Maybe they broke their intake and now they can't score. They're just playing defense. So an exponential moving average basically, so under the covers, the way it works, you take a number, and then you multiply it by the alpha and add the next number. And then you take the next number, etc., and then it turns into this crazy curve. So the alpha number basically says, are you weighting? Sean, I think you explained this already, but are you weighting the numbers more recently, a lot heavier, or the history more? So the 0.4 was weighting the more recent numbers a lot heavier. 0.15.
It's actually more like it's more even. It's close to even, but it is more heavily towards the past, a little bit towards the past history.
Oh, by the way, correct me if I'm wrong, but I don't think we actually mentioned where we're taking the numbers from. I don't think we mentioned the contributed point statistic yet.
Oh yeah. So when you fill up,
actually, I was trying to fill. I think I was talking to space.
Oh right, when
yeah, I was trying to
recording.
show the JSON how we have these calculated metrics. That
Yeah,
when someone says I've scored a ball in the upper in auto, we calculate that as, that's 4 points you just scored.
Yeah, when you get when you fill out your match scouting form, all of those little tick boxes, like did they taxi, did they hit upper or lower, or did they climb, that's all turned in the back end. Each of those things has a point value, and that's put in the back end. All that's tallied up into a contributed points metric. There's some problems with that. We're trying to work out, like the defense doesn't really, like, defense is kind of like whatever in there, and it tracks on the other team and not the team who's doing the defense, but that's the statistic we used for the match predictions and this data analysis.
Yeah, measuring defense effectiveness is definitely
It's difficult. It's
Yeah,
difficult.
we'll definitely want to figure out a way to include that. It'll be difficult. We'll figure something out to include defense.
And if we do include defense, we can always use these this stuff again to see if it's better with or without extra defense statistics. So
at some point, perhaps that Ben or Thomas or your line or somebody can come in on that, because I know we had a lot of spirited discussion on that during the season and such, on the Discord. So definitely an open topic. Looking for ideas.
Yeah, that's all I have. I'm not sure if anybody else has anything else to ask or say, but I think we went over everything that I've been working on the past couple months. I know Callum has something lined up soon. I'm not sure when, but
I think we talked about 2 weeks. Callum, does that still work for you?
probably.
Okay.
Yeah. Sweet. Okay. I'm excited for that one. But yeah, thanks for coming, everybody. It's fun.
Thanks so much for having this and
Yep.
sharing the info. And thank you for coming, guys.
Yeah, thanks.